Hello everyone. Welcome to my channel. Today we will discuss LeetCode question number 841, which is keys and rooms. So let's read the question. It is given that there are n rooms leveled from 0 to n minus 1, and all the rooms are locked except the room 0. And your goal is to visit all the rooms. However, you cannot enter locked room without having its keys. When you visit a room, you may find a set of distinct keys in it. Each key has a number on it, denoting which room it unlocks, and you can take all of them with you to unlock the other rooms. So, given an array rooms, where room I is the set of key, and you can obtain if you visited room I, return true, and if you can visit all the rooms, return false. If you can, yeah, you have to return true if you can visit all the rooms, else you have to return false. So you will be given an array rooms that is a vector of vector, and each index is each index of this room is containing an array which is consisting the keys of other room. Okay, so room 0 will be unlocked. So you will go to room 0, and whatever keys are there, you will take that, and you can unlock those rooms, the key that you are having, and you will unlock those rooms. You will get keys to next rooms. So in this way, you have to tell whether you are able to visit all the rooms or not. If you are able to visit all the rooms, then you have to return true. Otherwise, you have to return false. So let's see the example test case. So here rooms is given 1, 2, 3. So you are having the key of room 0. So you will go to room 0, and in room 0, room 1 key is there. So index is 0, 1, 2, 3. So room 0 key you have, you came here and you get the key to room 1. So you went to room 1 and you opened and you get key to room 2. So you go to room 2. In room 2, there is a key to room 3. You went to room 3. Room 3 is empty. So in this way, you can see that you visited all the rooms. Since you are able to reach all the rooms. So the output is true. Now let's see the another example. So index is 0, 1, 2, and 3. So you have key to room 1. So you came to room 1. At room 1, you got keys of room 1 and 3. So you went to room 1 and you went to room 3. So in room 1, you got keys to room 3 and room 0 and room 1. So room 0 you already visited. You already visited. This key is of no use. And the room 1 is itself. So this key is also of no use. And you are having key of 3. So from here you can go to room 3. But room 3 or you have already visited, and it contains keys to room 0. So room 0 you already visited. So you can see that you are not able to reach this room 2, room which is at the index 2. So you are not able to visit room 2. So in this case, the output is false. So now let's discuss the approach how we can solve it. Okay, so we can solve it using DFS. DFS. What we will how we can solve using DFS? So you are having key to room 1. So you will go to room 1, and whatever keys you got, you will go you will make another DFS call. Means you will make a DFS call and you will provide the room number 0. Okay. And in that you got keys 1 and 3. So you will make a DFS call for room 1 and room 3. DFS call for room 3. And you will maintain a maintain a array uh, where you will mark whether you visited that room or not. So if the size of room is 0, 1, 2, 3, 4, so you will make a vector of 4 size, and you visited room 1, just mark it that you have visited, and it has keys 1, 3, and you made a DFS call to 1, 3, so it will go to 1, it will go to 1 and 3. So again you will mark, you visit 1, so you will mark room 1 visited, and from here you will make DFS calls. You will make DFS calls only if it is not visited. So 3, you can see that it is not visited, so you will make a DFS call. Mm, yeah, DFS call you have already made for 3. But this will be called only if DFS call to 1 completes. Okay, so here also it will make a DFS call to 3. Uh, Now 0 is already visited and 1 is already visited, so it will not make any DFS call for this. Now it will go to 3. 3 is having 0, so 3 will be also marked as visited. So index 3. Now it is having key 0, so 0 is already visited, so it will not make any DFS call. So this DFS, this will return. So this DFS call ends. This is called through DFS 1. So this DFS calls will end, and this DFS 3 will go here, and so 0 is already visited, so it will return. So this will also end. So after that, you will check your visited array. If all of them are visited, then you will return true. Else you will return false. Okay, so let's see the code. So I have made a recursive function, which is a DFS function. So let's start from the main function. Here I have taken in the size of the room and created a visited array of size n, and called this DFS function, and provided the room and the starting room, which is 0, and pass the visited to mark it. So it will come to this. Here I have marked this visited true, whichever index it is called, and I am exploring all the adjacent rooms, means uh, whichever keys it got of that in that room. So it will check if it is visited, then it will make a DFS call, else it will not. And after this function, I have run a for loop, and I'm checking is any room left unvisited. If so, it will return false. Else in the end, it will return true. So let's run this code. Yeah, it passed all the given test cases. Let's submit it. Yeah, it passed all the given test cases. So uh, time complexity time complexity for this will be O of n, as we are visiting each rooms only once using this DFS call. So time complexity will be O of n, and space complexity will be O of n, which we have taken for this visited array, and another O of n will be for the stack space that is being used in this recursive function. So that's it. Thank you for watching. Do like, share, and subscribe.